Hey there, welcome to lesson 15, inverse functions. So today, given a function, given a function in context, describe its inverse function. Oh my goodness, some days, I feel like I say it every lesson, but yeah, I'm going to take this one step further. Hold on, I'm going to push pause and write it. All right, I think more importantly to your understanding would be this second one. Understand that the inverse of a linear function can be found by reversing the process that defines the initial function. So when we say function, it can be anything like, I don't know, the cost of one of your problems in your homework has been the cost of a meal plan in college is based on the number of meals, like, I don't know, 3 plus 4n or something like that. So that's the linear function. Now the inverse is reversing the process. Okay, so yeah, we could say, I don't know, c equals 3 plus 4n. If I subtracted 3 from both sides and then divided by 4, I could figure out that each meal, I don't know why I did m, it should be n, the cost of one meal, right? If we reverse that process. All right, so let's move on and actually start working. So here is an encoded message, a message that has been converted into a code. Can you figure out what it says in English? How is the original message encoded? Okay, I'm terrible at these. I know if I looked at the alphabet, I could figure out that let's see, Q, R, S, T, U, V, W, X, Y, Z. Now I'm pretty sure that nope, I didn't mean to do that. So I'm just trying to figure it out. If I move everything back 4, does that work? So L, 1, 2, 3, 4. V, 1, 2, 3, 4. Nope. Oh, that's only 3. Haha. Let's try again. Three. Let's see L. 1, 2, 3. V. 1, 2, 3 is, yeah, so there we go. I've moved back 3. 1, 2, 3. G. R. 1, 2, 3. O, O. 1, 2, 3. Yep. Good. So something is a good G. 1, 2, 3. D. D. 1, 2, 3. B. 1, 2, 3. Something is a good day. 1, 2, 3. T. R. We already figured out was O. Today. Today is a good day. So we have an encoded message and a rule. Let's see what we're doing. How was the original message encoded? So our input minus 3, basically. Our output equals our input minus 3. That's terrible. Okay, all in the alphabet. Basically, if our output was, say, D, oh, no, it would be our input plus 3. If our input was A, let's change colors. If our input was A, we would plus 3, 1, 2, 3, and get our output. Okay, so our output is our input plus 3. If our input was G, plus 3, 1, 2, 3, our output was J. All right, so if I wanted to write the word mom, I would say 1, 2, 3. I'd input M, I'd output P. I'd input O, 1, 2, 3, R, and then I'd input M again, and I'd output P. Okay, pretty cool. All right, now it's your turn to write a secret code. Write a short and friendly message with 3 to 4 words. Pick a number from 1 to 10, then encode your message by shifting each letter that many steps forward or backward in the alphabet, wrapping around from Z to A as needed. Consider using this table to create a key for your cipher, cipher being the answer. I would actually like everyone for a 10-point quiz grade. Send me an email. Let's see, you're going to watch this lesson on the day that you're going to watch it. This is lesson 15. You're going to watch this lesson on that day. It's due. I will tell you in class when it's due, but it's going to be due on your quiz day. Okay, I can't write it down here in case I use this lesson again, but please make sure, and I'll put it in Blackbaud for what I'm using, but email me, okay? 3 to 4 words is your rubric, and make sure, all right? It says give your encoded message to your partner, me, and if requested, give the number you used. Cool? All right, now moving on. Suppose M and C each represent the position and number of a letter in the alphabet, but M represents the letters in the original message and C the letters in your secret code to complete the table. So, letter in the message. Use M and C that can be used to encode an original message into your secret code. Now, this is still part of what you're doing for your quiz. An example would be like our warm-up. An example would be our warm-up was, let's see, M is the original, so for the warm-up that we did, C is the secret code, so secret code equals the original plus 3 as an example, the one from above. Okay, the code was the regular input plus 3. All right, so as I said, when I put in the letter M, I got out the letter P because it was M plus 3 gave me P. Okay, so go ahead and do these as part of your email to me. All right. U.S. dollars and Mexican pesos. An American traveler who is heading to Mexico exchanges some U.S. dollars for Mexican pesos. At the time of his travel, $1 can be exchanged for 19.32 pesos. So pesos equals dollar plus 19.32. At the same time, a Mexican businesswoman who is in the United States is exchanging some Mexican pesos for U.S. dollars at the same exchange rate. So here we have dollars equals pesos minus 19.32. All All right, the first thing that really helps to find an equation, right? And these equations are inverses of each other because I can take the first equation and solve it for D. Right? Gets rid of that, and I end up getting this equation. P minus 19.32 equals D. Or I can take the second equation and find the inverse of that by adding 19.32 to both sides. And I get that equation back. All right, I'm going to erase all that. So find, try not to erase the original. There we go. It says to find the amount of money in pesos that the American traveler would get if he exchanged $100. So pesos equals $100. Ooh, I didn't do that right. Nope, I did all of that wrong. You know what? I'm going to leave it up there because I want you to see it. It's so funny. I love making mistakes for you guys. Truly, I don't, but sometimes it's great because you see that I'm a regular person who makes regular people mistakes. Okay, so if we have $100, what it really means is $1 equals 19.32 pesos. And 1 peso equals 1 over 19.32 dollars. Okay, that's the inverse of each other. All right, sorry about that. So pesos $1. There we go. Oh my goodness. I really should re-record this lesson. Do not push stop. Do not give up. All right? Please. So, American travelers heading to Mexico exchanges some US dollars for Mexican pesos. At the time of this travel, $1 equals 19.32. Let's just keep it at that, pesos. At the same time, a Mexican businesswoman who's in the United States is exchanging the Mexican pesos for US dollars at the same exchange rate. Let's just do this right here is my exchange rate. Period. Do not move on. Now, if we have $100, how many pesos do we have? So if $1 equals 19.32 pesos, I'm going to set up a ratio. $100 equals how many? All right, just going to cross multiply, and we're not going to use X. We're going to use P. So cross multiply, I get 19.32 times 100. So pesos equals, I move my decimals, 1,932. Okay, just forget everything I did in that until this point. Now, $500. So $1, I'm going to set it up like this time. $1 is 19.32 pesos. Set it up a little bit different. $500 equals, I'm not sure how many pesos. So cross multiply, and I get 500 times 19.32 is 9,660 pesos. Okay. Write an equation that gives the amount of money in pesos as a function of the dollar. So here we have pesos equals 19.32 times your dollar amount. Okay, each dollar times 19.32. So $1 times 19.32 is 19.32 pesos. $2 would be double that. $3 would be triple it. 100 would be times 100. All right, so find the amount. Sorry. Businesswoman exchange. So same thing. $1 equals 19.32 pesos. I don't know how many dollars. 1,000 pesos. $1, 19.32 pesos. We're not sure how many dollars equals that many pesos. So 1,000 equals, I'm cross multiplying, that's an equal sign in there. So multiply down 1,000 equals $19.32, and then divide both sides. I get dollars equals $51.76. All right, let's try it again. 5,000, and we're going to set up the ratio different. So $1 over 19.32 pesos equals $1 equals how many dollars over 5,000 pesos? So cross multiply. I have 5,000 equals 19.32D. Divide both sides by 19.32. Divide by 19.32. I have dollars equals $258.80. Explain why it might be helpful to write the inverse of the function you wrote earlier. Okay, this right here. This one right here is solved for pesos. It took a little bit more work to get to dollars, but if we just said dollars is equal to the amount of pesos over 19.32, it's helpful because then I don't have to do any rearranging of my equation when I'm using my equation over and over. So these two are inverses of each other. All right. Now, these two here. When we had an input of $100, we had an output of, what was it? That's not 100, so sorry. That was 200. If we have an input of 100 pesos, 200, 400, so 100 is going to be here. Our output should be about 1,932 pesos. So my input to my output. And then the other one we did was $500. So $500 input, output of $9,660 or pesos. Now we can flip it and go the other way. The other two we had were 1,000 pesos and 5,000 pesos. So 1,000 pesos is how many dollars? So we go input to output. 5,000 pesos, was that the other one we did? Yep. 5,000 pesos input, hit the line to output. Domain and range. Okay, so these two graphs are inverses of each other. Cool? All right, that is it for today. Good job. I'm sorry again about that whole whatever.